So let's price a 6% bond with semi-annual coupons and a principal of $100 that matures in 3 years. Well, first let's figure out what all that means. A 6% bond means that they pay me every year 6% of the principal, so of the $100. So I get $6 a year for the coupons. But semi-annual means I get half the payment at 6 months and half the payment in a year. So for a 3-year bond, in 6 months I get $3. After a year I get another $3. A year and a half, $3. 2 years, $3. 2.5 years, $3. 3 years, $3. Oh, and also at the end of that 3 years I get the $100. So that last payment at year 3, the end of year 3, is $3 for the coupon and the $100 principal. So that 6% is just telling me how big the coupons are. I need to discount that cash flow. That $100 I have to wait 3 years for, so it's not going to be worth $100. The coupon that I get in 6 months, that first $3 coupon that I get in 6 months, that's worth more to me, present value, than the $3 I have to wait till 2.5 years to get. So I have to discount all those cash flows to present value. In fact, that's how we price the bond. The bond is just the present value of all its cash flows. What's the present value of the $3, then $3, then $3, then $3, then $3, then $3, then $100? So the interest rate that we're going to use to discount the cash flow is the 2%. So that would be the interest rate that would be in the market at the time when we're pricing this bond. Our first job then is to calculate what's the discount factor, what's V. Well, with 2%, that's just 1 over 1.02. And our discount factor then is 0.9708. No. 0.98034. 04 about. So that's what we're going to discount the cash flow. And let's deal with this then just by drawing the cash flow out. This is us at year 0. Now I have to concern myself with there's half a year, there's 1 year, there's 1.5 years, there's 2 years, there's 2.5 years, and there's the final 3 years. So 6% bond means I get $6 a year, but semi-annual coupons, that's normal. Semi-annual coupon is a normal way to do a bond. I get $3 at the end there, $3 there, $3 there, $3 there, $3 there. Here I get $3 plus the $100 principal back. Now, I need to discount these $3. So 3V. Oh, but what about that V would be if I had to wait a year. I only have to wait half a year. So raised to the half, square rooted. That's for 3V because I wait a year. 3V to the 1.5, 3V squared, 3V to the 2.5, and this is worth $103, but I have to discount it for 3 years. So calculating the present value of all those pieces of cash flow, this first $3 is worth $2.97. This second one is worth $2.94, then $2.91. I mean, they're worth less and less because I have to wait longer and longer to get them. $2.89, $2.85, and the final payment is worth $97.06. Now, I'm rounding these off to the penny. What we should do is write out all the decimal places and then sum them up. So the present value will just be the sum of all these present values of cash flows. When I add those up, I get $111.62. So this bond should sell for $111.62. It's a $100 bond. Why do I have to pay more for it? Well, it sells above par. Par would be if it sold for $100. Oh, well, that makes sense because I'm getting 6% on my money. Well, it's paying 6%, but the discount rate is only 2%. So it makes sense that it's selling for above par. To make this sell for at par, where the present value of all these cash flows would actually equal $100, I would have to set I equal to 6, or buy a 2% bond in a 2% market. Then it would exactly equal to $100. In upcoming videos, we have to worry about things like, what's the yield of this thing then? I seem to be implying that it's 6%. Well, we got to figure out what that means. What's the yield? What's the current yield? What's the duration is another term we need to talk about, and convexity. We'll have to calculate that for an upcoming bond. But right now, we'll content ourselves with, we've priced this bond, just looking at it as a series of cash flows.